Why does it matter what control groups you use in classical conditioning and which one is the right one? Stay tuned. Now, I admit, control groups don't seem very sexy at first, especially in comparison to those experimental groups traipsing around with their independent variables hanging out. But I hope after watching this video that you'll be able to recognize the beauty that was right in front of you the whole time in the control groups. I'm going to be using classical conditioning language like CS and US, so if you're a stranger to that kind of talk, check out my other video on the basics of classical conditioning, then come back to this one. In an experiment, you make comparisons between an experimental group and one or more control groups. The goal is to manipulate one variable and see if it makes a difference. So the control conditions allow you to control for other variables that might also explain any differences observed. That way you can be sure it's the variable you're interested in that made the difference rather than some other variable. One of the things I admire about the field of learning is its tradition of rigor in the experimental design. This sometimes means that experiments get complicated with multiple control groups to eliminate alternative explanations. By helping eliminate alternative explanations, control groups are what allow you to make the claim that you're trying to make. They ensure that what you say made the difference is what actually made the difference. But not all control groups are equally good, and some might lead you to the wrong conclusions altogether. So let's look at some examples and talk about what some good and not so good control groups might look like. First, let's see what happens when we have no control group. Let's say that we're going to train a dog that the word bed is associated with treats in the dog bed. The word bed will be our CS, and treats will be our US. Our procedure will go like this. Every few minutes, I'll say the word bed and toss a treat on the bed to pair our US and CS together. I expect an unconditioned response, or UR, one that doesn't have to be learned, where the dog approaches the treat. This should happen from the beginning. But after a few hours of pairing the CS and US together, saying bed and tossing a treat, I expect the dog to develop a conditioned response, CR, of approaching the bed. Now it's time for a test. After 100 treats, I shout bed, and this time I don't toss a treat. Does the dog go to the bed? Yes, the dog has learned to approach the bed when I say bed. Now, as a pet owner, I'm done. Simple, right? Now when I say bed, my dog knows where to go. But if I want to be a scientist studying this situation, I have a bit more of a job to do. I have to figure out how to measure the conditioned response. One approach might be to draw a line around the bed and measure how much time they spend inside the bed versus outside the bed in the 30 seconds after I say bed. As learning occurs, I would see an increase in time spent in this goal area, the bed. In order to make sure this wasn't a fluke, I should probably do this with multiple dogs and multiple beds. But how do I know it is due to the pairing of the CS and US that this occurred? Could some other things explain this increase in time in the bed area? Maybe the food made them slower or lazy, so they spend more time in the dog bed anyway. Maybe I could say any word or make any gesture and the dog would still go to the bed area, which is something called pseudoconditioning, which might need its own video. If the CS or US by itself can increase the time spent in the bed, then you don't need learning to get the change in behavior. This is a callback to our video on Morgan's canon. If you can explain it in terms of simpler behaviors, those are more likely than the more complex behavior. To eliminate these alternatives, we need a control group. So what are our options? One might be what we would call a CS alone control. In this case, we could have a group where we just shout bed, but we never toss a treat. That way we know that any change in behavior isn't just due to the familiarity with the CS. Likewise, we could do a US alone control group, so we could ensure that the change in behavior wasn't due to sensitization or habituation to the US. Both of these have a problem though. The differences in exposure to the CS or the US might explain the difference in behavior you get during the test. For example, if it's the first time I've said bed for a US only control group, that could explain the difference in behavior that isn't due to learning. Maybe the dog is just scared by me shouting at it and hides under a table. Robert Bob Rescorla, one of the most influential scholars in the field of learning, wrote a critical paper on this topic in 1967 in the highly influential journal Psychological Review. In this paper, he identifies no fewer than 6 commonly used control procedures and showed how they are all inadequate to allow you to make the claim that it was learning through pairing of the CS and US that accounted for the differences between groups. So how do we make sure that it is due to learning? To show this, the change in behavior must be due to the pairing of the CS and the US together. Everything else should be equal. This means we need a control group that gets both the US and the CS, but the CS does not predict the US. Imagine the experience of a dog in this control group. Occasionally, I toss a treat to the dog bed. Every now and then, I shout bed. But saying the word does not reliably lead to a treat in the bed. Will the dog learn to associate the CS with the US? Will I get a conditioned response? Both the control group and the experimental group had the same number of exposures to the same US and had the same number of exposures to the same CS. The only difference is whether the two were paired or not. If the control group and the experimental group perform exactly the same, that suggests that pairing of the variables made no difference. There was no learning. On the other hand, if there is a difference between the groups, we can be confident that it was due to learning to associate these two stimuli together. But strap in, it's time for some nuance. Nuance. Presenting the CS and the US as paired in the experimental group and unpaired in the control group isn't as easy as it sounds. What do we mean by unpaired? We actually have some options here. One option is to have the CS and US occur totally randomly, which we'll call a truly random control procedure. Imagine that we had a random number generator determining when we said bed and when we tossed a treat. Sometimes there would be treats, sometimes we would say bed, and there would be no noticeable pattern to it. But sometimes, just by random chance, we would say bed and toss a treat at the same time. This means that the two would be paired together on those trials. Doesn't that mean that they could learn to make an association between them through those pairings? This makes many researchers uncomfortable, so they opt for another option. They occasionally deliver a CS and occasionally deliver a US, but they make sure to never have them occur together. We call this an explicitly unpaired control because we are explicitly saying that these two will never be paired. As you can imagine, this idea is very alluring, so this is a really common approach. But as Rescorla points out, this creates a new contingency. If you have a CS, then you can't have the US occur for some time after that. This means that the CS might serve as a sign or signal for the absence of the US. Maybe the dog learns that if I say bed, there won't be a treat for some time. So this means learning in the control group might account for any group differences that we might see. Rescorla's advice? Use the truly random control. He even identified some issues with this approach, but ultimately gave a roadmap for how to do it in such a way that it could escape these kinds of criticisms and could be dubbed, in his words, adequate. But do people listen? No, they don't. Lots of people who study learning still use explicitly unpaired controls. To make things worse, many outside of learning, with people in backgrounds such as biology or other fields, may not even be aware to do that. So this is why we need collaborators across the sciences to help each other out, to ensure that we're making rigorous, high-quality science. If you'd like to help us out, hit the like button. We've got more videos on the way, so subscribe if you like discussing all things psychology, and until next time, keep thinking. Okay, Marry, Kill, Pavlovian Control Groups Edition. Ready? Go.
What do you want? You want to explicitly unpaired?
It's got explicit in the name.
No.
Plus it's unpaired, so it'll leave me alone in the morning.
Oh.